So in this video, we're going to be looking at disproportionation reactions, which is going to be a specific type of a redox reaction itself. Now remember from module 2 that a redox reaction, it involves two things. It involves, of course, the gain in electrons, but it also involves the loss of electrons as well, both reduction and oxidation. If you were to look at our halogens, right, our halogens are very special because, of course, all of them apart from fluorine, they can actually have oxidation states outside of 0 and -1. They can have variable oxidation states, and this is very important because it actually means that they can get involved in disproportionation reactions. A disproportionation reaction is a specific type of redox reaction, but this time, right, we've got the simultaneous oxidation and reduction of the same element. So we've got, of course, something like chlorine, a halogen, and it's going to be oxidized, one atom of it, and the other atom is going to be reduced itself. Now halogens, they undergo these disproportionation reactions when we react them with cold dilute alkali solutions like sodium hydroxide or potassium hydroxide. And in the example that I've shown you here with chlorine, we can actually bubble chlorine gas through a solution of cold dilute aqueous sodium hydroxide to make bleach, right? In other words, to make sodium chlorate solution itself. Now if you were to look at sodium chlorate, right, you need to think, what's the formula of that going to be, because you need to be able to write balanced equations for these. Well, sodium plus looks like that. Chlorate means I've got chlorine and oxygen in there, because if it ends in 8, we know it's an oxyanion. It's got an oxygen contained within the actual ion itself. And we're going to have chlorine, and then we're going to have oxygen. We need to think chlorine is going to be +1 in this case because we're given the oxidation state. Oxygen is -2, and of course the overall charge must therefore be -1 itself. So the formula of bleach that's actually formed is going to be sodium, and then it's going to be chlorate like this itself. Now if you were to form an overall equation for this process, this disproportionation equation, I would end up with chlorine as a diatomic molecule reacting with sodium hydroxide, and what I end up forming is of course sodium chlorate, as we've already mentioned, and then I also end up making sodium chloride and then water as well. Now the thing is, what's changing in this equation is I've got chlorine here, two atoms within this diatomic molecule, and chlorine is going from a 0 to a +1 oxidation state over here. It's been oxidized, and it's also going from 0 to a -1 oxidation state here. It's been reduced itself. So we know, of course, because we've got the simultaneous oxidation and reduction of the same element, we know we've got a disproportionation reaction. Now if you were to balance this, we would end up with 2 lots of sodium hydroxide, and there's that equation done. If I were to look at the ionic equation, right, I would have again chlorine reacting, and we get rid of the spectator ions, which in this case is going to be sodium, and so I'm left with 2 lots of hydroxide reacting, and that's going to react to form, of course, chlorate as an ion. It's going to form chloride ion, and then it's going to form, of course, water as well. And there's my ionic equation there too. So moving on, that's how we can actually make bleach, which is used in many different things, like in cleaning water, in cleaning toilets, and of course bleaching textiles. What about another reaction with chlorine, another disproportionation reaction with chlorine? Is going to be with water, and this is how we actually clean swimming pools, where of course we end up forming chloric 1 acid in solution itself. Now of course we're going to do the same thing over here. We're going to take chlorine and we're going to react that not with hydroxide, but we're going to react it instead with water itself. Now of course you can see over here I've made HCl. The next thing of course I'm going to make is chloric 1 acid, which is going to look something like this, HCl, and then it's going to be O itself. There's another equation that we need to be able to remember, and of course it balances as it is on its own. Now if we're ever asked to explain why this is going to be a redox reaction, of course what we can do is state the oxidation state of the substance changing in our actual equation itself. So in this case chlorine 0 here, it's going to be -1 there, it's going to be +1 there. We know chlorine is going to be of course oxidized from 0 to +1. It's also going to be reduced from 0 to -1. We know we're going to end up with a simultaneous oxidation reduction of the same element, and so we know it is going to be a disproportionation reaction. Now HClO is actually quite important because it's got the characteristic ion in there, which of course if HClO is going to dissociate, we can actually end up forming H+, which isn't that important, but more importantly we can end up forming chlorate ions, and these chlorate ions are very special because of course they're antibacterial. So yeah, here I've got another equation that I need to remember, and of course I need to be able to explain why the top one is going to be a disproportionation reaction. So moving on then, one of the questions that we could actually be asked in the exam is to explain how a reaction is going to be classified as a disproportionation reaction. Normally I would go about defining what disproportionation is. I would look at the change in oxidation states and the oxidation states in the individual species itself. Feel free to pause the video and have a go at the following question. Resume once you're ready to go over the answer. So you're looking at this one, we're asked to use oxidation states to explain how the following reaction is a disproportionation reaction itself. So we need to find in this, right, an element that's going to be simultaneously oxidized and reduced itself. And the one that we're interested in is actually going to be chlorine in this case. Of course, I'd recommend that you would find the oxidation state of everything and then look at what changes. But chlorine here, it's going to be 0. Over here on the right hand side, it's going to be -1, so we know it's been reduced. If I were to look at this over here, I've got sodium, which is going to be positively charged here. I've also got chlorate, which is ClO3, that must be minus. I need to find the oxidation state of chlorine. Well, +5 is going to be, of course, the oxidation state of chlorine, because all the oxygens is -6. -6 to -1 is going to be +5 itself. So I know the oxidation state of chlorine within this. Now, in terms of oxidation, I can see my chlorine going from 0 to a +5 oxidation state. In terms of reduction, it's going from 0 to a -1 oxidation state itself. Now, how would I actually word something like this in the exam, because it normally comes up as a 3 to 4 marker? I would need to tell the examiner, first of all, what is a disproportionation reaction? It's when we have the simultaneous oxidation and reduction of the same element. I would then tell the examiner the different oxidation states, so in this case chlorine, where I've got it 0 in Cl2, -1 in NaCl, and +5 in sodium chlorate itself. And now all that I've got left to tell the examiner is, of course, in terms of redox, chlorine is going to be oxidized from 0 to +5 oxidation state, and then reduced from 0 to -1 oxidation state itself. And a lot of the times they actually combine this mark together to make it one mark. But of course, this is how we lay it out in terms of the exam. Now that's done, feel free to pause the video and have a go at this slightly more challenging one. Resume once you're ready to go over the answers. So yeah, we're told again to use oxidation states to explain how the following reaction is a disproportionation reaction. Now, chlorine over here is going to be 0, calcium's +2, oxygen is going to be -2, and then hydrogen's +1. Calcium, oxygen, hydrogen, they're not changing, so we don't need to worry about those at all. If you were to look at chlorine though, right, chlorine on the right, it's going to be -1 over here because we've got chloride ion. If we were to look at chlorine in this case, right, because calcium is going to be +2, that means OCl must be -1. So we've got OCl and then minus as an actual charge for that ion. If we were to look at oxygen, if that's going to be -2, and of course chlorine, that must be the difference between -2 and -1, so that would be, of course, +1 itself. Now, if you were to look at the changes in oxidation state, we're going from 0 to -1 for chlorine, and then 0 for +1 in terms of chlorine as well. So we know that we've got the simultaneous oxidation and reduction of the same element. That's what we need to tell the examiner. That's going to be the first marking point. And then, of course, we know chlorine in Cl2 has an oxidation state of 0, in CaCl2 -1, and then in Ca, OCl, and then 2 is going to be +1 itself. So we know chlorine is going to be oxidized from a 0 to a +1 oxidation state and reduced from a 0 to a -1 oxidation state itself. And again, another example on how we can answer these questions on disproportionation. So moving on then, we could be asked to give some advantages and disadvantages of using chlorine to treat water, as well as some alternatives as well. The main advantages is chlorine actually kills bacteria like cholera itself, making it safe to drink. It also prevents the growth of plant matter like algae, and it prevents any discoloration caused by these organic compounds decomposing in water. Some disadvantages though, of course, chlorine is going to be toxic and it irritates the respiratory system, and chlorine can also react with organic matter to form carcinogenic, which basically just means cancer causing chlorinated hydrocarbons. We can also end up with liquid chlorine in some cases, which is dangerous to deal with because of course it causes chemical burns on skins and eyes, but in most cases we use it in very, very low concentrations itself. Some alternatives that we can use is ozone and UV light itself. ozone is a strong oxidizing agent and that can kill microorganisms, and then UV can kill microorganisms by damaging their DNA. Remember, it's ionizing radiation. Now, a problem with ozone, a disadvantage is that it's expensive to produce and it doesn't really last for very long because, of course, ozone is going to be an unstable molecule. UV, of course, is going to be ineffective if the water is dirty and it blocks the radiation itself, and it's only effective short term as well. So there are some benefits, disadvantages, and some alternatives to using chlorine to treat water that we need to know.